Math first, physics later? When we take projectile motion and put it early in physics, students end up not understanding the physics of projectile motion. Physics shouldn't ever be just a math exercise, solving a bunch of math problems. It's not the best use of our understanding of physics time. We need to place this projectile motion at the end of mechanics. Because we only have a year. Most people quit after a year. And most students don't even take physics. Why we need to study projectile motion last. Let's learn physics. Projectile motion is commonly considered a pretty important thing in physics. Okay, it's not really, but we spend a whole lot of time with it. I remember when I was in high school and in college, the books started with like speed and velocity and solving a bunch of problems with what we call kinematics equations, and then went straight into projectile motion, solving a bunch of problems before we actually got into any of the physics. Here is the Giancoli textbook. Introduction, measurement, and estimating, and then describing motion, kinematics in one dimension, then kinematics in two dimensions, and then chapter 4, we start physics. So all those chapters 1, 2, and 3 are all about math problems so that you can get to the physics. Chapter 4 is the first physics. That's a dumb approach, but it's a really common approach. This is Surway and Fawn. Chapter 1, the science of physics, motion in one dimension, motion in two dimensions, and vectors is chapter 3. And then chapter 4, forces and the laws of motion. We convince our students that physics is all math, and then we start doing physics. And here we have Young and Geller, or Sears and Zemansky's, or something. It's College Physics, 8th edition. Unit conversions for chapter 1. Chapter 2, motion with constant acceleration. Chapter 3 is projectile motion, and chapter 4 is Newton's laws. This is the AP approach. It's the New York State Regents exam approach. And this is Glencoe, Physics, Principles and Problems. Chapter 1, a Physics Toolkit. Chapter 2, representing motion. Chapter 3, accelerated motion with free fall. Chapter 4 is forces in one dimension. And then chapter 5, they switch it a little bit, displacement and force in two dimensions. And then chapter 6 is projectile motion. So now we're starting to see some variation from that. And that standard, start with kinematics and then go to the physics. It isn't constant, but we think that's the way we must do it because that's the way all our college courses did it. Ostiak and Board. Physics, Inquiry into Physics, a student-tested, faculty-approved approach to teaching and learning physics. Chapter 1, the study of motion. Chapter 2, Newton's laws. So they get the velocity and acceleration first, just the terms, and then you get into Newton's laws, and then energy conservation, and then physics of matter, and then the temperature and heat, and then it's a skinny little book. And they deal with projectile motion in a few sentences in this book. It's a really interesting approach because honestly, projectile motion, we should be looking at that as a part of Newton's laws, but spending weeks solving free fall problems. College Physics, Reasoning and Relationships by Nicholas J. Giordano. Chapter 1, Introduction. Chapter 2, Motions, Forces, and Newton's Laws. And then Chapter 3, Forces in Motion in one dimension. Chapter 4, Forces in Motion in 2 and 3 dimensions. And then Circular Motion and Gravitation, Work and Energy, Impulse. It's actually pretty good. Chapter 4, after Newton's Laws, a section or two on projectile motion. Hewitt's Conceptual Physics. I've been using this one since about 90 or 91 in college when they instituted the program there. Chapter 1, this is the high school version. You can tell because the print is bigger and the pictures are nicer and there are fewer questions. But chapter 1, about science. Chapter 2, mechanical equilibrium. Vectors, introduction to vectors. Chapter 3, Newton's first law. And then 4, linear motion. And then chapter 5 is projectile motion. And then chapter 6, Newton's second law. Okay, now that approach right there, you do projectile motion before Newton's second law? Wait a minute, Newton's second law is the reason why the things follow that arc. That doesn't make any sense. And then Newton's third law, then momentum, and then energy. So other than really, I would take projectile motion and put it after Newton's second law. It's a decent approach. Check this one out. This is a higher level conceptual physics version by Hewitt. And this thing, I really like it, hope to adopt it for next year. But chapter 1, science, just introduction to science. Chapter 2, Newton's first law, so we do first law. 3 is linear motion, then we do Newton's second law, third law, and then 6 is momentum. Momentum and conservation, and then 7 is energy, and 8 is rotational motion, and 9 is gravity. You're like, where are the projectiles? The projectiles are where they should be. Projectile motion and satellite motion grouped together after you've studied all of Newton's laws, after you have all that information, understanding. Rotational motion is already done. They've already dealt with centripetal force. This book puts it where it should be. So let's say that you've done Newton's first and second and third laws first. You already understand Newton's laws of motion. You go to projectile motion after all that. Sketch a free body diagram on your papers right here. The free body diagram is just the weight. And you're like, what does that weight actually do? Oh, that weight being the only force is the thing that is causing all of the acceleration, because you know Newton's second law, net force equals mass times acceleration. Whatever the direction of the net force is that causes that acceleration, that's the direction of the acceleration. So here I have this weight that is causing the arc, it's causing the change in direction, that's the centripetal force. And you also have a backward component of it. So just like the inclined plane, you can take the weight and split it into two components. One that is parallel to the motion is going to cause the change in speed, what I like to call the tangential net force, and the one that is perpendicular to the motion, the centripetal, toward the center. That weight does both things, causes the change in speed and the change in direction. And you can see as it goes through here, like, that's pretty fascinating. At the very top, that weight is the centripetal net force. That is exclusively causing direction change. Curved is the greatest at the top because the change in direction is the greatest at the top. And that's why this is parabolic motion. So as you reach the peak and come down off the peak, the closer to the peak you have, the larger the perpendicular component and the larger the rate of change of direction, because that's centripetal acceleration. And as you go up, the change in speed is the largest, and the change in speed is smaller, and the change in speed is 0 at that instant at the top. And then as you're going down, you're picking up speed, because the parallel component is in the same direction as the velocity, and you're picking up speed and picking up speed even faster down here. The rate of change of speed is larger, but the rate of change of direction is smaller. I mean, this is really good, complicated stuff, and you're building images in their brains, and that's what you're supposed to be doing, not like solving math problems in velocity and projectile. No. Take the projectiles and put them after Newton's first, second, and third laws. Take the projectiles and put them after centripetal force and here, because this stuff makes sense. And then you can take this stuff, and then you can put it together with an elliptical orbit. And the elliptical orbit makes a whole lot more sense because, using Newton's second law, I can split the component of the weight, that gravitational force between the central object and the satellite, into its two components. One will change the speed, one will change the direction. Oh, that's why I have this elliptical orbit. Fascinating stuff. Physics shouldn't ever be just a math exercise. It becomes a real exercise in understanding what's going on here and why it's happening. So if you find yourself in your class solving a bunch of math problems first, like, all right, we're going to have to understand speed and velocity and acceleration and projectile motion, and you're annoying your students because you're convincing them that math and physics are the same, or that physics is all math, dude, you're doing something wrong. Now, I know you have to do it if you're following the AP curriculum in the New York State and the California and the Texas. I don't care. That's just a stupid approach. This book right here, the only book I've ever seen that approaches projectile motion in the correct way and puts physics before solving a bunch of math problems. This thing is it. So get out there and change your physics curriculum and put projectiles last where they belong. Thanks for watching Learn Physics, and thanks for that thumbs up too. Really helps a lot. New videos most academic weeks. Subscribe for more. I've even got education ideas, Freaky Physics Friday, and Tech Tip Tuesday. And for bicycles, motorcycles, and family adventures, it's my other channel, Bike Physics. You just learned physics.